Welcome to a new data science project. In this video, we are going to create a customer segmentation project using the k-means machine learning algorithm. We are going to have a dataset about customers and we are going to do clustering with the dataset. We are going to do data analysis, data cleaning, feature engineering. We are going to create a clustering model, and at the end, we are going to create a Streamlit web app for getting predictions from our model. I'm going to be sharing the dataset that I'm using in this video in the description. You can follow that link for downloading the same dataset. Let's start to our project. Here's the data card of the dataset that we are going to be using in this video. It's a customer segmentation dataset, and let's take a look at it together. So it says customer personality analysis involves a true examination of a company's optimal customer profiles. So I'm going to be leaving this link in the description of this video. You can just download the data from the download button for following the codes in this video. And let's see the features. We have ID, birth year, education, marital status, income, kid home, teen home, daytime customer, recency, the amount spent of wines, fruits. We probably sum all of that. Amount meat. And we have like number of deals purchases, number of store purchases, accepted completion, Z cost contact, Z revenue, and response. So we are going to create a clustering algorithm from these features, and we have 29 columns. We are going to analyze this data a lot more on Jupyter Notebook. Just want to show you the data card, so you can download the dataset from this download button for using the dataset. Again, I'm going to be re-recording in my code editor. Let's start coding. So I'm going to be using VS Code for this tutorial, but you can use any code editor that you want. And here I downloaded the dataset customer segmentation.csv. It's in here. You need to put it in the same directory that you are going to create Jupyter Notebook and Python script for directly using it like me. And also I have the link in here saved, so I'm going to share it with you. So let's directly start by creating a analysis and model.ipmb. So we are going to have a Jupyter Notebook like that. I'm going to select my kernel like 3.11.4 of Python. Then I'm going to create a code cell for the start. Firstly, let's do our imports. I want to start by importing the pandas and NumPy. Then I want to create the visualization libraries like import matplotlib.pyplot as PLT, and also import seaborn as SNS like this. After that, we can load our data. So how we can do that is we can just say pandas read CSV, and then we can directly pass the customer segmentation.csv inside of this. And if we assign this to something like data frame, now it's going to be in here. And let's see like how it's loaded by using dataframe.head. So it loaded successfully. So let's take a look at these columns. Again, we have ID, year, birth, education, income, kidom. We can see them all. So let's just call the columns. We have these columns in here. I'm not going to repeat it once again. So let's directly see the shape for seeing the row count. We already know that we have 29 columns, but we have 2,240 rows. Okay, so let's call dataframe.info for getting a general information about our dataset. We can see the data types, the range index, and stuff like that from here. So we can see that we have one float, 25 integers, and 3 objects. Great. So let's see if we have any like missing values on this data cleaning side. So I will say data frame is an A, and it's going to return booleans true or false cell wise. And if I say sum, it's going to return me column wise this null counts. We have 24 in here. So if we just say sum again, we are going to see the complete total. We have 24 NA values. So let's just drop them. I'm going to say data frame drop NA. And when I do that, they are not going to be dropped. Like, let me show you. It returns a data frame. And when I call this line again, I'm just going to copy and paste. We are still going to see 24 because we didn't assign this new data frame. We didn't modify the original data frame we have. So what we can do is we can either do data frame equals to this, or we can pass a parameter like in place equals true. So in this way, it's going to modify the original data frame, and when we call the isNA, it's going to return 0. So we don't have any NA values right now. Okay, so we can get this summary statistics for numerical columns right now. We are going to call data frame describe, and here we can see that year birth, income, kidom. Let's see the income. So on the income side, our mean is 52,000 and standard deviation is 25,000, which means that the data is spread well. And at the maximum side, we have 666,000, and on the minimum side, we have 1,700. And also I'm going to check for other stuff. Let's see the last column on the response side. So this is the mean, I guess. Let me check. Yeah, the mean is 0.15 on the answering to the marketing mails or messages. So people are more likely to not respond, which sounds realistic. Okay, so let's see unique values for categorical columns. So I will say data frame education, and let's see the value counts on that. So we have graduation 1100, PhD 481, master 365, second cycle we have 200, basic 54. So let's also see this information for the marital status. I'm going to call value counts on that. So married 857, together 573, single 471, divorced 232. Okay, so let's do some data cleaning and feature engineering. At the first place, we are going to convert the date column. So data frame datetime customer is going to be pandas to datetime data frame datetime customer, and we are going to say day first is going to be true like this, and I'm going to make it run. Actually, we are not going to put underscore on that side. Okay, great. So right now when I call data frame info, we are going to say we have datetime in here. Let me check the previous one. It was like object. Yeah. Okay, so it's a datetime object right now. Next, let's calculate the age. So data frame age is going to be 2025 is this year minus data frame year birth. So we are going to have a column like this. We can see the age right now. Also, we have columns like, let me call data frame head again, like kid home and teen home, but we don't know the total children number. So data frame total children is going to be data frame kid home plus data frame teen home. So we are going to have a column like this right now. Also, as we talked in the Kaggle page, we don't have something like total spending. We have them separately, like let me call data frame columns again. We can see that we have different like sale numbers. So for the total spending side, let's do like spending columns are going to be wines. So it's going to be like this, and fruits and meat products and fish products and also we are going to say gold products. So after creating this, the spending columns, what we are going to do is we will say data frame total spending. Let's name it like this. It's going to be data frame spending columns dot sum, and we are going to say access equals to 1. So we are going to have something like total spending side. We are going to have something like this right now. We have the total spending information. And also let's get the customer tenure. For that, we are going to say data frame customer since, and in here we will say pandas timestamp, and we are going to take the date of today in here minus data frame datetime customer like this, and we are going to say datetime dot days. So on the customer since side, we are going to have this. Awesome. So right now let's do some exploratory data analysis. At the first place, let's get the age distribution. So for that we will say seaborn histogram plot. I'm going to call data frame age, and let's set the bins like 30 and KDA equals to true. So also I'm going to give it a title like age distribution, and also I will say plt.show in here. So we are going to have something like this. We see that our mean age is like 50 and the oldest is 85 kind of, and the youngest is like 20, and it's well distributed. Okay, let's also see the income distribution. So seaborn histogram plot, data frame income, and bins is going to be 30. Let's say KDA equals to true again, and title is going to be income distribution, and let's also use plt.show again. So at the income side we have a plot like this. Okay, let's also get the same information for the spending distribution. So we create the column as total spending, which we are going to use a lot. Let's use that like total children, not total children, spending. Let's say bins equals to 30 and KDA equals to true, and plt.title like total spending distribution, and we will say plt.show like this. Okay, we can see that we have a lot more data on the less spending side, which can be expected. It makes sense. Okay, now let's do some categorical analysis. So let's compare education and income. So seaborn box plot, I will say X is going to be education, Y is going to be income, and data is going to be data frame. Let's say X tags in here, rotation 45, and title is going to be income by education level, and we will say plt.show. So here we can see that the highest values on the PhD side and the lowest values on the basic side. Let's also get the same information for the marital status. So seaborn box plot again, we will say X is going to be marital status, and in here Y is going to be total spending, and we will say data equals to data frame. Again, I will add rotation 45 like this, and I will say title spending by marital status, and I will say plt.show in here. So we can see that the highest values are on widow, and we see that single side is coming second. Since there is no a lot of observations in the absurd and YOLO side, they are not important. Okay, let's do correlation analysis. So for that we will say correlation, and we are going to specify the columns that we are going to use, like income, age for sure, this and C can be taken, and let me call the data frame.columns for remembering what we had. So what we can do in here is we can do total spending for sure, and we can do like, let's say, number of web purchases, and let's also do number of store purchases. Okay, cool. So we are going to have a data frame like this right now, and in here I'm going to say seaborn heat map. I will pass correlation data frame, and that is going to be true, and let's set the cover map as cool warm like this, and let's give it a title like correlation matrix, and let's do plt.show. So it's going to be in here in second. Also, I forgot something. We need to say that correlation in this side. Then I'm going to run this. Now we are going to have correlation matrix in here, and I'm going to rerun this plot, and we can see the correlations right now. So we can name like more than 50, like 0.5 values as positively correlated, and more than 0.3 we can name it like low correlation. Like in here, we can see that total spending on income is correlated, which we can just think of. It makes sense. Also, total spending and number of store purchases with number of web purchases related, as we can expect. And we don't have really negative correlations. I want to remind you that correlation can take values between 1 and -1. 1 means that the values are positively correlated. -1 means that the values are negatively correlated, which means that they are going to move in the different directions. And a value closer to 0 means that it's not really correlated. Okay, great. So let's continue. Let's do like a pivot table. So I will say pivot income, and let's find like average income by education and marital status. So I will say data frame pivot table, and values are going to be income, and index is going to be education, and columns are going to be marital status, and aggregation function is going to be mean. So in here we are going to have something like this, and we can create a heat map with this, like heat map pivot income, let's say, and true. Also for seeing the percentages, I will say format floating, and color map is going to be, let's apply something else in here like Y, L, G, and BU. And in here, let's say PLT.title, and we are going to say average income by education and marital status. And here it is. We can see our heat map in here. Let's continue by finding average spending by education. So for that, I will say like group 1, and it's going to be data frame group by. I'm going to group my data by education, and I'm going to take the values of total spending, and I will call the mean after that, the aggregation function that we are going to use. And also let's pass sort values. I don't want to be in the ascending order like this. So we are going to have something like this right now. Great. Right now, let's visualize this. So I will say group 1.plot. Let's create a bar chart, and color, let's say sky blue. And I'm going to give it a title, like let's say average spending by education. And I'm going to give it a Y label, like average total spending. And let's add the X tags, like rotation is going to be 45, and I will use plt.show at the end. Here we can see that PhD is the leader. Okay, let's find campaign acceptance rate by marital status. So I'm going to create a combined accepted any campaign indicator, like data frame accepted any is going to be its name, and I'm going to say like data frame, and in here I'm going to say accepted 1, accepted campaign 2, and accepted campaign 3, and also accepted campaign 4, like this. And then I will say like accepted campaign 5, and also the response. And at the end I will say sum, and axis is going to be 1, like this. Great. So I'm going to call accepted any right now. Here we can see that, let's actually get the unique values. Here we have like, since we take the sum, if the user accepted all of them, we got 5 in here. So we need to format this quickly. So I will say data frame accepted any is going to be data frame accepted any, but apply, I will say lambda x is going to be 1 if x is greater than 0, else it's going to be 0, like this. So when I call this again, we are only going to see, we will have 1s and 0s like this. Great. Now we can do our group by, like group 2 is going to be data frame group by marital status, and I will say accepted any.mean like this. And next up I will say sort values, and ascending will be false like this. So let's see what we have in here, group 2. And here we can see the accepted rates, and we can just create a plot. So group 2 dot plot, kind is going to be bar, color will be, let's say, orange this time. Actually, I will do like that. And next, what I'm going to do is I will say title campaign acceptance rate by marital status, and I will say PLT Y label acceptance rate, and also the capital letter in here. X text, I will say rotation 45 plt.show. So let's get this. So we see that the campaign acceptance rate is lowest on the together and highest on the absurd side. Okay, so let's create a final plot, then we can go with clustering. So I will say I want to find that average income by age groups. So firstly, let's create age groups like bins, and I will pass 80, 30, 40, 50, 60, 70, and let's say 90 after that, not 80. And next I will say labels. It's going to be like 18 to 29 and 30 to 39, and I will say 40 to 49 and 50 to 59 and 60 to 69, and I will say 17 plus after that. So right now I will say group 3, I'm going to say data frame group by, and in here I need to create a column for passing that. So for that I will say data frame age group, and it's going to be pandas. I will use the cut function data frame age, and I will pass like bins are going to be bins, and labels are going to be labels like this. So let's see the age group column we created right now. Here it is. It seems great. Now we can group it by this age group, and we are going to take the income.mean. So I think it's a really great finding tool. Let's see the group 3. We can see it. Like, let's create a bar plot again. Group 3.plot, and I will say kind is going to be bar horizontal, color is going to be green, and title is going to be average income by age group, and X label is going to be average income, and I will say plt.show after that. So here we can see that older people have more income. Now let me call the data frame again. We are going to go with the segmentation, and we have a lot of columns as you can see. Also let me call the data frame columns here, and let's select 5 or 6 different features that represent customer demographics and behavior. So let's take age, I guess it's a demographic, income, demographic again, total spending, let's take it also, it's on the spending side. Let's also take number of web purchases, it's the online activity, number of store purchases, it's the offline activity, and let's say number of web visits month, it's the engagement, and also let's include the recency, like the recency interaction side. So let's filter our data frame like this. I will say features, and it's going to be age, income, total spending, number of web purchases, and number of store purchases, and number of web visits month, recency. And now I'm going to save this up, this list, and I will say X is going to be data frame features, and let's copy this. So in here, actually, there's a typo. It's going to be capital letter like this. So I'm going to save this up, and I will call the X So we have a data frame like this to work with right now. Awesome. So right now let's do a pre-processing step. I want to scale this data because our ranges are different. So I will say from scikit-learn pre-processing import standard scalar. Next up I will say scalar, and it's going to be equal to the standard scalar like this. After this initialization I will say xScaled is going to be scalar fit transform, and I will pass x in here. So on the xScaled side we are going to have different values than x. Like, let me call it and let's see it together. Here is our values. And we are going to use k-means for the clustering. It's a really popular algorithm, and we need to give a k, like the grouping number, which is the number of clusters. And there's a way to determine the optimal number of clusters called elbow method. We are going to apply that. So firstly, we will say from scikit-learn cluster import k-means at the start, and also after this let's create a empty lists on the inertia like this. And in this empty list what we are going to do is we will say for index in range, let's say 2 to 10, k-means is going to be k-means. We are going to initialize it like this, the thing we imported in here, k-means like this with the capital letter on k, and we will say number of clusters is going to be I, and in this for loop we will say k-means dot fit x scaled, and then we will say inertia list append k-means dot inertia. So in here we are going to have values like this, and let's plot this because it looks better. So let's plot the able curve like range 2 to 10. We will say yes, and let's also add a marker on this plot with inertia. So title is going to be elbow method for optimal k, and x label is going to be number of clusters, and y label is going to be the inertia, and we will say plt.show in here. So in here we need to select the one where the elbow bends. Both the 4 or 6 will work in this case. I'm going to take the 6 since I think it's better. So we are going to initialize it like k-means is going to be right now k-means. I will pass number of clusters. It's going to be 6, and I will say data frame cluster. Now I'm going to do a fit predict on the xScaled side. So I'm going to have a cluster in here in my data frame like this. Now let me call the data frame. Again, we will have a cluster at the end on our original data frame. Now let's analyze this cluster. That's the important point of this project. Like, you are going to create the characteristics of the clusters, like let's say cluster 1 is the older people with more income and stuff like that. So for that what we can do is we can say like, let's call cluster summary, and I'm going to say data frame group by. I'm going to group by cluster, and I'm actually going to fix the typo, group by, and I will say features like this, and I will take the mean. So when I call the cluster summary, I'm going to have something like this. For cluster 0 we have the mean age of 55, for cluster 5 we have 44, and we can see different income numbers, like cluster 5 is the most with income, and cluster 1 here is on the total spending side has 978, and the lowest value is on cluster 4. Like, we have this information right now, and let's see the cluster counts, like data frame cluster and value counts. Here we can see that on the 4 we have like 561, and with the least value on the cluster 3 we have 230. Why these clusters matter is because when you have clusters to customers, you can specialize the marketing campaigns, and also the prices, stuff like that. So if you can predict the cluster of a customer, then it's going to be pretty easier to run your marketing stuff. You can even change the cold emails and stuff like that. Okay, let's visualize the clusters using PCA, Principal Component Analysis. So I will say from Scikit-learn, the composition, import PCA, and I will say PCA is going to be PCA. I'm going to initialize it like number of components of 2, and PCA data is going to be PCA fit transform, and I will pass X scaled, and I will say data frame PCA1 and data frame PCA2, and I will say PCA data like this. I will take the first and I will take the second like this. I will say 1. So in here I'm going to say like PCA data, we are going to have something like this, and on the data frame PCA1 side we have a column like this, and PCA2 we have a column like this. Now let's create a scatter plot. So seaborn scatter plot, X is going to be the PCA1 and Y is going to be PCA2, and hue is going to be the cluster, and I will say data is going to be a data frame, and let's set the palette of set 1. And next up what I'm going to do is I will say title customer segmentation, and I will say PCA like this, and I will say plt.show. So here we can see our segmentation, and I think it looks great with 6 clusters we have in our data. So again, I'm going to call the cluster summary. If you want to make this project more advanced, what you can do is you can just analyze these clusters. Like let's say that on cluster 0, I'm just giving an example, you can name like cluster 0 high income, high spending, and cluster 2 you can say high web purchases, low store purchases. And in here, by the way, these are just examples. Cluster 0, they are not the high income and high spending side. Just giving an example, you can say like premium example, premium customer to this cluster, and on the other you can say like digital buyers. And let's say that on the cluster, let's say 5, you have low recency, inactive, then this means that dormant customers. It's up to you, like you can just determine them and it's going to be better project for sure. Let's say cluster 6, even we don't have it in here, so I'm just giving examples. Let's say low income, low spending, which means that budget customers. If you can just define this from the summary, it's going to be much better project. So now we have the model in our notebook, but we want to turn it into a Streamlit app. For that, we firstly need to train model and train scaler to be exported. So I will say import joblib. Next up, I'm going to say joblib.dump k-means, and I will say k-means, like name it like model.pickle. It's going to be a pickle object, and also I will dump the scaler. We need to use the same scaler that we used on our data for the new unseen data. So when I make this run, they are going to be in my directory. Like here we have the k-means model.pickle with scaler.pickle. So we are done with notebook. In here we did a lot of analysis, feature engineering, data cleaning, and we modeled our data. We have 6 clusters right now. So right now we can move to the Streamlit app creation part. We can close our notebook. And what I'm going to do is I'm going to create something like segmentation.py. And in here, what I'm going to do is firstly, we need to do our imports. Like I will say import Streamlit as st, import pandas as pd, import numpy as np, import joblib. And next up, we firstly need to load the model and scaler. So for that, k-means is going to be joblib.load. I will say k-means model.pickle. It needs to be the same name with the thing that we exported in here, and scalar is going to be joblib.load scalar.pickle. And next up, what we are going to do is we are going to give our app a title like streamlit.title customer segmentation app, and we will say streamlit.write enter customer details to predict the segment. So if you just keep it in the notebook, like this notebook, only you are going to be able to use that. But think of that, we are moving this to the web app right now, and your marketing department or any department that wants to work with this segmentation model can use that. So the importance of this project is, and all of the data science project is, if your model is getting used, then it's useful. If it's on notebook, it's not really useful. Okay, so now let's continue with our app. We are going to create the input fields for the selected features, the things that we have on the X side. So age, income, total spending, number of web purchases, number of store purchases, number of web visits, month, and recency. So for that, we are going to go like age, and we will say income, we will say total spending, and next up we are going to say like number of web purchases, and we are going to say like number of store purchases, and we will say number of web visits and recency. So for that, let's start with age. I will say Streamlit, age is going to be the number input, age, minimum value is going to be 18 and maximum value is going to be 100, and let's set the default value like 35. And next I will say income, so number input, income, the minimum value in here is going to be 0 and maximum value is going to be 200,000, and let's set the default value like 50,000. Next up, let's continue with total spending. So we will say Streamlit number input, total spending, and also since this is an added feature by ourselves, let's add a mini description like sum of purchases, and I will say like minimum value is going to be 0, maximum value is going to be 5,000, and value is going to be 1,000. So let's continue. Now we have the number of web purchases. So for that we will say Streamlit number input, number of web purchases, and minimum value is going to be 0 again, and maximum value, let's say 100, and value is going to be 10 for default. You can change these values, by the way. You can change the value or maximum minimum value depending on the case or the app that you want to build. And next up I will say like number of store purchases we have. For that I will say number input again, number of store purchases, and we will pass minimum value, maximum value, and I'm going to set the value like 10 again. And let's continue with number of web visits. So Streamlit number input, number of web visits per month, and let's again define the values like 0. Let's add maximum value 50, value is going to be 3 in the side, and for the recency we will say Streamlit number input, recency. Let's also add a small description like days since last purchase, and I'm going to say minimum value, maximum value 365, and value defaultly will be 30. Okay, great. So we have all those ready in here, and next what we are going to do is we are going to collect our input into a data frame. So let's say input data for that, and it's going to be pandas data frame, and I will say like, let's start with age like this. It's going to be age, and income, it's going to be income, and total spending. Here we will pass the total spending, number of web purchases, it's going to be number of web purchases, number of store purchases, it's going to be number of store purchases, and number of web visits months, and it's going to be number of web visits, and at the end we are going to say recency, and we are going to have recency like this. So we have 7 features. Now we are going to scale the input with initialize scaler in here, which is trained in the original data. So for that we will say input scaled is going to be scalar dot transform, and we will say input data. And next up we are going to add a button, like if Streamlit button is going to be predict segment, and which means that if the button is clicked, this inline is going to be working. If it's not, it's not going to be working. So we will say cluster, and it's going to be k-means that predict input scaled, and we are going to take the prediction in here, and we are going to say Streamlit success, and we can say predicted segment is cluster, and we are going to pass cluster. Also, as we talked in the notebook, like if you just define the segments, you can add something like Streamlit.write, and then you can say like in here segment, or let's say cluster 0 high budget web visitors or stuff like that. And you can add like cluster 1, you can add like high spending, cluster 2 web visitors, and stuff like that. You can write it on here if you decided to add that in your project. So we have this ready in here. I'm going to save this, and let's test our app. So I will call Streamlit run segmentation.py. So it's going to open the app in the browser, like it's just going to be opened on your localhost in here. If it's not opened, you can just directly copy this address, the HTTP localhost 8501, and if you paste this address on your browser URL, you are going to be go into the app. So I'm going to be recording on my browser right now. So here's the app that we created, and I think we have a typo on the recency. Let me quickly fix that from code. I don't need to change anything. Like I will say recency like this, and I'm going to save from my code. So you can see at the top source file changed. I will say rerun, and we have that fixed. So here we have our app, and I'm not going to change anything at the start. So let's say like predict segment. So predicted segment is cluster 5. So let's change some values and try this again. So I will say like income is going to be 20,000 and total spending is going to be 2,000. And let's see if our segment is going to change. It's cluster 5 again. So maybe we can make change on like age, and we can change like, let's say 15 on this, and see the segment. Now it's cluster 2. And let's change the income, like let's say 120,000 like this, and let's set the age like 80. So let's see the cluster on this. It's 2 again, and if we decrease the age, I think it's going to change like, yeah, it's cluster 5. Okay, so our model is successfully working behind, and we have our web app ready. Great. Let's get a final prediction, like let's say total spending 5,000 and age 60 and income, let's say 30,000. So let's make it run like this, and here it is. Predicted segment is cluster 5. Great. So I'm going to be recording back in my code editor right now. Our project is completed. Okay, so I'm going to close the app right now, and let's summarize what we did on this side. We imported Streamlit pandas numpy joblib. We loaded our scaler and the model. Next, we create a title and we say Streamlit write, enter customer details. We take the inputs and then we create them a pandas data frame with the input data. Then we scale our data and we create the button for predict segment. And then we run our model, we predict the new data, and we display it on screen. Great, that was it for the project. Thanks for watching. Let's get to the outro. Thanks for watching this data science project. I have a playlist named Data Science and Machine Learning Projects where I have more than 30 videos just like this one. You can reach that playlist from the cards of this video or from the link in the description. Also, I'm sharing a new video every week on my channel about data science. You can subscribe for more. Have a great day.